My name is Jill Heinerth, and I'll be your host and guide for a remarkable evening with an extraordinary group of explorers and scientists interested in the submerged caves of Mexico's Yucatan Peninsula. You may have already seen announcements on global media platforms, but tonight we have an opportunity to learn about these finds firsthand from the researchers and explorers illuminating the long lost secrets of early humankind in Central America. Tonight we dive deep into an underwater cave, an ice age mine, to look at life in the Pleistocene and Holocene. The discovery of human remains in underwater caves of the Yucatan is rewriting Paleo-American history. We know now that people were in the region earlier than previously thought. This team is beginning to discover what they were doing there. This project goes beyond the important scientific discoveries. It represents the synergy of a multidisciplinary team that is only made possible through cooperative efforts of private individuals, NGOs, educational institutions, and government organizations, such as Mexico's National Institute of Anthropology and History, INA, the body tasked with documenting and protecting the nation's antiquities. In the spirit of cooperation, this exploration group does their work in the memory of a pioneering archaeologist, the late founder director of the underwater archaeology arm of INA, Dr. Pilar Luna. She was the second underwater archaeologist to receive the important J.C. Harrington Medal for her work. This team embodies her passion for collaboration that makes the interpretation of sites like La Mina possible. As you will learn this evening, the discovery of a submerged ice age mine has married pure exploration and technological innovations that show us the future of multidisciplinary research and educational outreach. Tonight, you will hear short presentations from 7 team members: Roberto Junco, Silvina Vigliani, Dominique Rissolo, Jim Chatters, Brandi MacDonald, Eduard Reinhardt, and Sam Meacham. I will introduce each speaker for a short 3 to 4 minute presentation of their work that will be followed by questions from you, our global audience on Facebook and YouTube. Please submit your questions via the chat function and watch the chat for further information and links. We'll answer as many questions as we can in the hour that we've allotted, and we'll follow that Q&A with a special short film presentation. On this kickoff event of the International Year of Caves and Karst, I also want to thank the Explorers Club and specifically Ann Passer, Deanna Weibel, and Kevin Murphy for supporting this event from behind the curtain. So please allow me to introduce our first speaker, the esteemed archaeologist and project director, Dr. Roberto Junco. Dr. Junco directs the Underwater Archaeology Office at Mexico's National Institute of Anthropology and History, researching shipwreck and submerged cave sites around the country. He'll be sharing an overview of the project, as well as priorities for conservation of artifacts and sites in Mexico. So over to you, Dr. Junco.
Thank you so much, Jill. It is truly a pleasure to be here with you guys tonight at the Explorers Club. It's an institution that I've followed for quite a while. I've been in a couple of expeditions where the flag has been lent, the flag of the Explorers Club has been lent to us, and we've carried that flag in some of our expeditions. Let me start with a brief presentation on what it is we do in Mexico. As you know, Mexico has over 11,000 kilometers of sea coast in the Pacific Ocean, the Gulf of Mexico, the Caribbean, Gulf of California, and thousands, literally thousands of bodies of water, like rivers, lakes, lagoons, where we find underwater cultural heritage. So underwater cultural heritage studies in Mexico started in the late 19th century, when Del Paso y Troncoso started an expedition with hard hat divers to look for shipwrecks. So we have quite an old story of looking and investigating underwater cultural heritage. Our heritage inside the water comprises the prehistoric sites, the pre-Hispanic, of course, sites that mainly are in lakes, lagoons, and rivers, oftentimes with an inclination to ritual practices related to the gods of water, etc. Of course, shipwrecks from the colonial period, both in the Pacific and in the Gulf, and certainly the shipwrecks like steamers from the 19th century and 20th century. For example, gold rush era shipwrecks in the Pacific coast, etc. The aims of our organization at INA are to investigate, to do research, to do conservation, of course, to apply the law. In Mexico, the law is very explicit. We're signatories of the UNESCO 2001 Convention on Underwater Cultural Heritage, and as such, all this heritage is protected by the law. And of course, along with being signatories of the convention, we follow the best practices guidelines of the convention, and thus we do courses for underwater archaeologists in Latin America, for example, to get everybody on board the convention, and of course in Mexico. And definitely one of the key points is also to share all this research being generated, all these investigations and all these sites that we have. And as such, for example, we have an underwater archaeology museum in Campeche, or for example, we do publications of all kinds for the general public, for kids, for the scientific community, etc. So those are more or less our aims. Our cultural heritage is very, very large in a span of time, of course, not 14, 15,000 years, and all the country, from Baja California to the Yucatan. And I just wanted to briefly tell you that last November, there was an expedition financed by the Explorers Club to look for the steamship SS Independence. And thank God we were very successful. We found the place where it sank in mid-19th century off the coast of Baja California. And this was a grant generated by the Explorers Club. So I would like to encourage the Explorers Club to keep helping research being done here in Mexico. There's so much to do, and very exciting heritage that we have. Let me pass the word now to my colleagues. Thank you.
All right, thank you so much, Dr. Junco. Your efforts in bringing this team together and protecting the assets of Mexico's resources and the outreach initiatives are so important. Our second speaker this evening is joining us from Chiapas. Dr. Silvina Vigliani is an anthropologist, archaeologist working in the areas of hunting and gathering and rock art archaeology. Dr. Vigliani will help us to understand the prehistory of the region so that we can better visualize what the Yucatan was like during the last ice age. So over to you. Silvina, you may be muted. Silvina, I think you may be muted.
Sorry. Hi, everybody. Listen to me. Sorry. Well, I'm going to give a brief introduction about what we know and what don't know about the early human presence in Yucatan. For a long time, it was believed that human presence in the Yucatan Peninsula was no more than 4,000 years old. But since underwater archaeological exploration began in caves and cenotes of the region about 20 years ago, we know that humans arrived at least by the end of Pleistocene. The Yucatan Peninsula is a large limestone platform that includes one of the most extensive cave systems in the world. This now submerged system of caves were dry and accessible from the last glacial maximum until the middle Holocene transition, about 13,000 to 8,000 years ago. And it's just when we have the first evidence for human presence. After that, most of the cave flooded during sea level rise and preserved the evidence. Up to date, the oldest evidence of human presence at Yucatan were found in cenotes and folded caves along the coast of Quintana Roo. No cultural remains have yet been located on the surface or in dry caves. The findings correspond to the remains of at least 10 individuals, 10 human skeletons found in different cave systems and dated to the Pleistocene-Holocene transition. The study of these bones had allowed us to know many of their lifestyle and their evolutionary process. For example, the oldest human skeleton is a woman named Naya and dated at 12,800 years. She was found at the Hoyo Negro site where remains of extinct fauna were also located. Jim will talk more about that. A few remains of bonfires of possible anthropic origin were also reported and the water too. And that's all. We still don't know anything about the material culture of these people nor where they made their camps, but we know something about them through their bones. Finally, the question was, why did these people go deep into this cave where we're dry and accessible, but involved great risks? Some hypotheses proposed access for fresh water, temporary shelter, ritual or intentional burial of human remains. But since La Mina site was discovered in 2017, we know that one of the reasons was exploration and mining of red ochre. La Mina site is a large ochre outcrop with clear evidence of prehistory mining activity, like a large number of pits for ochre extraction, broken stellothems and piles of debris everywhere, broken flugstone, broken speleotheme used as hammerstone, etc., etc. Studies show that the mining activity lasts for around 2,000 years, roughly 12,000 to 10,000 years ago. Since La Mina was discovered, other sites were identified as prehistory ochre mine, like Camino Mina and Monkey Dust. So, well, I finish here. So Dominique and the others will tell us more about this extraordinary archaeological site, which is La Mina. Thank you.
Thank you so much, Dr. Vigliani. And to our audience, we have people joining us from as far away as Malaysia, Israel, Jamaica, Ireland, all across the United States and Canada, and of course, Mexico. And just as a reminder, at the end of our speakers, we will have an opportunity for questions and answers that you can submit via the chat functions. And then we'll get to those and follow that up with a special short film presentation. Our third speaker this evening is Explorers Club fellow, Dr. Dominique Rissolo. As a research scientist and archaeologist, Dr. Rissolo has been working in the caves and cenotes of the Yucatan for over 25 years. Dominique brings engineering expertise to the team, and he'll be discussing the digital documentation and visualization of subterranean environments. So I'll ask Dominique to unmute and please present.
Hey, thank you, Jill, and thank you to my colleagues at INA for allowing me to participate in this project, and thank you especially to Sam for introducing me to all things underwater in caves and cenotes. Came to that a bit late, thanks to Sam and our late friend Bill Phillips. So I'm going to go ahead and share my screen, and we'll jump right in. Let's see. All right, so our lab at the Qualcomm Institute at UC San Diego focuses in part on multimodal data fusion and interactive visualization. Essentially, we develop tools and techniques to create 4D digital twins of submerged sites like La Mina, by integrating data from different imaging modalities, in this case, structure for motion photogrammetry, into a multi-resolution digital scaffold powered by our lab's point-based visual analytics engine. As we fly through this point cloud of Mina, you can see many of the features that we'll learn more about this evening. My colleagues at the Qualcomm Institute, Vid Petrovich, Eric Lowe, and Joel Polizzi, have been instrumental in facilitating virtual access to underwater sites. It's not just about creating models, it's about creating a means by which these image-derived data can be analyzed and interpreted, segmented, measured, annotated, or compared. Our lab's director, Falco Kuster, likes to say that we enable analytical reasoning by means of interactive visualization. And for sites like Hoyo Negro and La Mina, we can take virtual dives at full scale and in 3D in our immersive visualization environments, just a short walk from my office. Here we can explore, observe, and even plan. For researchers like Jim and Blaine and Vid here in 3D glasses, this might be as close as we come to some of these deep and remote places like La Mina. What is most gratifying for us is when members of the technical dive team see new things, new features or bones or spatial relationships in the data. I'll end there, and Sam will share a little bit more about documentation techniques and applications in just a bit. Thank you.
Thank you so much, Dr. Rissolo. Our next speaker tonight is reaching us from Seattle, and it's Dr. Jim Chatters. For over 50 years, Dr. Chatters has conducted archaeological and paleontological research, including publishing of more than 100 articles and monographs on his work. He is best known for studies of the earliest human skeletons from North America, including Kennewick Man and the very significant Naya of Hoyo Negro. He'll further illuminate a vision of humans during this time, as well as answer questions about dating submerged Paleo-Indian sites. So over to you, Jim.
Thank you, Jill. I just realized that I have to speak to turn myself on. I got drawn into work at La Mina as trying to help establish its reality as a human site and to determine its age. And I'm going to jump right into a screen share here. No, I'm not. Hang on. There we go. Okay, as Jill mentioned, or as Silvina mentioned, more than 10 human skeletons that are pre-Maya have been found in the Quintana Roo caves over the last 20 years. These individuals have been dated between around 8,000 years ago for one near the city of Tulum to the near 13,000-year-old Naya from Hoyo Negro, which is the one I work directly on. And Naya is found in a deep collapsed chamber and surrounded by the bones of more than 40 large mammals, including a number of extinct species like saber-toothed cats and giant ground sloths. We see these people dead in the caves, and so we know they were there, but what we don't have any idea of, or did not until 2 years ago have any idea of, was what they were doing in those caves and what they were doing in Quintana Roo in general, because there were no above ground sites either. What was found at La Mina was the first evidence we have of direct human activity in the caves besides being dead. As you can see here, there's broken flowstone floor, there's undercutting of the flowstone itself, and then people have taken the broken flowstone pieces and stacked them up on top like this.
Jim, sorry to cut you off. We just can't see your screen right now.
You can't?
Nope.
Well, that's strange because I'm looking right at it. Hang on. Do I need to go back and start over again? Is that the story?
It's up to you. Just make sure across the bottom on Zoom, there's the green share screen button. You want to click and make sure you're sharing through there.
I wish we'd gotten there before. Should I repeat myself? I'm showing my technology.
No problem. We can see it now.
Okay.
We can see your whole screen. So you want to go full screen.
There you go. Okay.
Perfect.
I'll repeat then, as Silvina mentioned, frequently human skeletons older than Maya time have been found in the submerged caves in Quintana Roo. They range from this individual here for an individual dated around 8,000 years ago, 8 to 9,000 years ago at Las Palmas, to Naya from Hoyo Negro, who dates almost 13,000 years old. And Naya's from the site of Hoyo Negro that is a deep underground collapse chamber that's been studied extensively for over 10 years. So we know that people are in the caves because they were dying there, but what we did not know was what people were doing in the caves, nor what they were doing in Quintana Roo in general, because no above ground sites have been found either. When Mina was first discovered, Sam shared with me pictures like this one, where we see undercut, broken off flowstone edges, undercut, deep pits adjacent to them, and then the flowstone that's broken off the floor stacked up on top. Clear signs of human activity. No other animal and no other process can create this. We also see numerous rock cairns. You can see this stack of rocks here, a nice little trodden trail in between, and then over on this side there's another stack of rocks that includes a large piece of broken stalagmite with red ochre stain on it. So somebody's red ochre stained hand placed this stone there. One of the most telling features is this breakage pattern of the flowstone floor. You can see this sort of crescent shaped breaks all along the surface, resulting from hammering by chunks of stalagmite like this one. You can see the battered edge here of this rather large, heavy hammerstone that was used to break the floor. So we can establish for certain that people were in there and that people were mining, but what we did not know for certain was when they got there, when they were active. One hint at when they were active in there is the fact that flowstone, in this case, these drips that you can see, this dripstone here, is covering up a layer of charcoal that may be a result of human activity, or may have been. So Ed Reinhardt, who you'll hear from in a little while, has collected charcoal from a number of these concentrations of charcoal in La Mina, and we run dates on those. Now, we've dated them and found that the La Mina itself was occupied between 11,400 and 10,700 years ago. The main activity, the big mined area that you just saw pictures of, that Dominique showed you. Other mining, both in Sagittario cave system and the other cave systems that Silvina mentioned, Monkey Dust and Camilo, ranges between 12,200 and 10,100 years ago, or at least the charcoal from those sites dates that. Charcoal is not necessarily the most reliable dating material in the caves. People often assume that it's there because of human activity, because people burn things, but in fact, nature produces charcoal in great quantities, especially in forested environments like the Yucatan. In Hoyo Negro, for example, we see tremendous amounts of charcoal that are probably naturally deposited. You can see them all across the top. The red arrows are pointing to them in association with this puma skeleton and a femur from a giant ground sloth over on the right. So what we did was to try and determine if we could distinguish the La Mina charcoal from the charcoal found in a natural deposit, Hoyo Negro, by identifying the species of charcoal that were represented. And that work was done by Barry Rock at the University of New Hampshire, who did scanning electron microscope studies of the charcoal fragments and found that there was a very large amount of non-torchwood, burned wood that wouldn't be good for producing light, in Hoyo Negro, and a very small amount of material that might be used as torchwood, like this one over here. And so torchwood was present in Hoyo Negro, but it was predominantly other things. In La Mina, however, all the wood was torchwood. It was things like that are called candlewood, torchwood, and copala today, but they're highly resinous woods that when they're burned, they have these very explosive chasms formed as the gases are released. So what that established was that this charcoal did in fact represent the human activity of the cave miners, and that validated the fact that La Mina was occupied and mined in Paleo-Indian times, and that was a very important discovery. It's the earliest mining activity that we have for ochre production in North America. So I'll hand it over now to our next speaker.
All right. Well, before we let you hand it over completely, Jim, I know that you have a very special little thing in your office there, and it's one of the byproducts of this incredible technology, because not only can you visualize these places through photogrammetry and other techniques, but you can take that data and do some 3D printing. So I think you want to maybe hold up that skull of Naya that you've got on your desk.
Okay. Yeah, this is a 3D printed and subsequently colored up, but skull of Naya from Hoyo Negro.
And how many, like, what's the resolution of that in sort of points per square inch, or?
Sorry, you're beyond me there.
Okay, no worries. But just to,
I'll give you another example. This is
Yep.
This is much higher resolution. This is at 1/10 millimeter resolution. So very small scale.
Amazing.
This is a giant ground sloth arm in 1/3 scale from Hoyo Negro, the same side as the skull comes from. So it gives you an idea of kind of what the capabilities are.
It's incredible to be able to, you know, print copies and then share them with other scientists too, beyond the data.
Yes.
Our next presenter is a fellow Canadian, actually, Dr. Brandi MacDonald. Dr. MacDonald specializes in archaeological science and provenance studies. She has a special interest in ochre use and rock art, studying the mineral composition and pigment properties of the ochre that was mined from La Mina. So please let me turn it over to Brandi.
Thank you, Jill. Hello, everyone. Yes, as Jill said, I am the resident ochre nerd for this project, and I'll share my screen here with you. I have a few images to share. So can you see that okay, everyone? Yes.
Great.
Okay, great. So I was invited to join this project by my colleague Ed Reinhardt back in 2018. And so my research focuses on the mining and use of mineral pigments in the past. So you can imagine how excited I got when Ed first started emailing me photos like this and showing me images from the early diving campaigns that were documenting the extensive ochre deposits and the evidence for human activity. So I was like instantly kind of hooked on this project. And so for me, the possibility of Pleistocene hunter-gatherers exploring cave systems to extract mineral pigments was a really exciting thing to think about. So for those of you who aren't familiar with ochre, here are a couple of key points to know. So ochre is a term that's used to describe minerals and rocks that are enriched in iron oxides. And these are the minerals that are used to make red paints, among many other things. And depending on its molecular form, the minerals can make different colors. So red, yellow, purple, orange, and black. And we know that hominids, humans and other hominids, including our evolutionary cousins, Neanderthals and Denisovans, were using ochre pigments as early as 300,000 years ago, if not longer than that. And the great thing about ochre from an archaeological perspective is that it's durable. So this means it survives in deep time archaeological records. So alongside things like stone tools, it's one of the few types of material culture that we can study to better understand the lives and behaviors of our ancestors. So during the late Pleistocene, ochre was quite a prominent feature of symbolic and ritual activities. So for instance, some of the earliest artistic expressions of cave art were made using red ochre pigments. But it was used for much more than that. It was also used in mortuary practices, so covering human remains or grave goods. It was also used to decorate small objects, personal ornamentation, such as beads or pendants, as body paint. It was even used to stabilize resins for hafting stone tools. So back to Mina. Ed had started to send me some of the ochre that they pulled from Mina during all their diving expeditions so that I could do some scientific analyses back in my lab. And my main question was, why was this particular ochre so important? When you consider how much effort went into going in the caves to get it, these folks must have valued it very highly. But it's important to remember that not all ochre is created equal. So there are different mineral properties that make it more or less desirable and effective as a pigment. So how do we evaluate its quality? In terms of things like hue and vibrancy, we ask, is this material color fast? So generally speaking, the higher the iron content of an ochre, it usually means it's a longer lasting and more durable paint. So the ochre from Mina, I found, was upwards of 80% pure iron oxide with very, very few mineral impurities. So this means there was less dilution of the pigmentaceous quality. The grain size is also a really important contributor to its color. It impacts how well the pigment can be dispersed into a wet medium to make a composite paint. And generally speaking, the smaller the grain size, the more evenly dispersed and effective a pigment will be. So the Mina ochres naturally have a very ideal grain size for high quality pigment. They're down to 1 micron particle sizes of paints. So when you combine all of these properties, my question about why the ochre was so highly prized was answered. What's effectively available at Mina is a ready-made pigment. So the ochre didn't require a whole lot of preparation in terms of mineral separation, so removing coarse particles or grinding down into a finer powder, or having to do other types of color enhancement like we see with lesser quality ochre deposits. The ochre from Mina, you could just gather, mix with a wet medium like water or blood or animal fat, and it's ready to use. So the next big question we have is, what was it used for? And the thing to remember is that we don't know for sure. Mina is an extraction site. And to determine what people used it for in the past, we would need to find its end use context outside of the mine. So for instance, if we could find Pleistocene age rock art or painted objects at other nearby sites, we might be able to interpret more on this one day. One of the really interesting properties we did identify with the Mina ochre is that it's very high in arsenic, up to 4,000 parts per million. So it's actually enough to repel pests. It could have been used as like a pesticide if you smeared it on your body. And that use is still up for debate, but it's just something interesting to think about. But the one thing we do know for certain is that the ochre mining would have been a kind of group level activity, and this knowledge would have been passed down from generation to generation. And it was really highly valued material, probably for a combination of reasons, one being the excellent mineral properties of the pigment. That's all I have to share with you about the ochre today.
Excellent. Excellent. Some of our viewers have been asking from Jim's presentation, there was ochre left behind on a speleothem. Do you have a sense of why that didn't wash away?
Well, it could be that Brandi can answer that question better because she's the ochre expert, but iron oxide is very difficult to get out if you want to remove it from something. It's very resistant to being washed off. Hence, we have tens of thousands of years old rock art on cave walls that have certainly been wet, or rock shelter walls that have been certainly wet at some point in time, and yet the ochre images that have been painted on them remain. So it's just resistant to being washed off.
Okay, thank you.
Even if you scrub it and use soap.
Yeah, thank you. Let me introduce our next speaker, Ed Reinhardt. Dr. Reinhardt specializes in geoarchaeology and coastal environments. He's been working on underwater archaeological sites since the early 1990s, first on ancient harbors in the Mediterranean and now on the underwater caves of the Yucatan. So please, Dr. Reinhardt, if you'll unmute your mic and present for us.
Okay, great. Hi, everyone. Thanks, Jill, and thank you everyone for joining us today for this presentation. I'll just get ready sharing a screen here. So as Jill introduced me, I mean, my background is geology, paleontology, micropaleontology, and coastal environments, and I do quite a bit of work in archaeological sites, and so work on geoarchaeological problems. I've been working in Mexico now in the Yucatan cave since about 2005, when I kind of first started, and we're doing a variety of different things, mostly paleo-environmental kind of reconstruction. In terms of this project, I'm kind of providing you know, context and environmental context in terms of flooding of the cave system and when that occurred, and then also input in terms of the actual ocher deposits, and so that's what I'll just kind of briefly talk about right now, and just give everybody a little bit of kind of context. I mean, some of the stuff has been brought up and mentioned by the previous speakers, but I'll go a little bit into a little bit more detail. So for those of you that have seen some other maps, I mean, we're basically working in this kind of area between Tulum and kind of Playa del Carmen. A lot of people have been there on vacation, you know, on vacations, perhaps even visited the cenotes there, and I think Sam will talk a little bit more about that. The area's got very, very extensive cave systems, and we're working in, or have been working on this project in Camilo, Sagittario, which is La Mina, and then also Borge or Monkey Dust down here. So we'll be talking a little bit about a couple of these sites. Basically, the Yucatan Peninsula is this carbonate platform, so it's made up of limestone. And this limestone it dates from Paleogene to kind of Quaternary in age, so millions to 100,000s of years old. And this limestone has been dissolved through the millennia, and it's so the caves are forming through this process of dissolution, which is like carbonic acid and humic acids within the soils. That is basically dissolving that limestone preferentially through beds of differing limestone and fractures. And through time, this then has formed the cave passages that we have today. All these cave passages, as Jim was mentioned, were dry at the beginning of the end of the Pleistocene, beginning of the Holocene. And they've subsequently become flooded through sea level change. So the last glacial period, all the glaciers melting, water going into the ocean, the water level coming up. Most people are pretty familiar with that. Very, very rapid rise up until about 7,000 to 8,000 years ago. And some of our research that we did on water level reconstruction in Sagittario basically affirms that it's largely sea level that is controlling whether the caves are wet or dry. So they were once dry and now have been flooded by a rising sea level. So this limestone is very, very porous. So what we have is we get rainfall basically percolating through that almost like a sponge of limestone. And the seawater, because of also this high porosity, the seawater basically intrudes from the coast. And that fresh water, that rainwater, which is less dense than the salt water, then rests on top of that salt water. So we get this fresh water lens or meteoric water mass, and then salt water down below. And this sort of, two water bodies are basically rising up with sea level rise. This is just to give you a little bit of a kind of context. So these are divers that are basically swimming at that transition between the salt and the fresh water, and that sort of oiliness that you see on the bottom is salt water, the transition to that fresh water. So this fresh water would have been a source of drinking water for people living on the Yucatan. It's part of my some of my other research is kind of reconstructing the potability of that water through time. In terms of ochre, as Brandi sort of introduced, ochre is what we would call in geology is a paleosol. I mean, it's being used as a pigment, and it's this iron-rich sediment. And these soils are forming presently. So there is some pockets and concentrations of this terra rosa soil, or these red soils on the Yucatan Peninsula. And they're forming through this, as I said, this process of dissolution that's forming our caves. But a process of dissolving that calcium carbonate then leaves behind impurities, which then become oxidized. And there's a lot of iron. Be a lot of iron that's left behind, as well as dust coming from foreign sources, from for instance the Sahara, that is landing in the peninsula and through time is accumulating and is weathering to produce this very vibrant pink color. So it does occur on the surface. We were finding it very, very extensively in some of these caves now, it is getting in, or is being included in, the limestone as these paleosols. We had some very initial questions about why were they going into the caves to take the ochre out. I mean, Brandi kind of touched on that in terms of the quality of the ochre product. But there is ochre on the surface, so why go to all the trouble of going into a dark, unlit cave to extract it? Why not just go to the surface and take some from there? And as Brandi mentioned, the actual quality of the ochre is much better from the actual cave system. So this is a figure from our paper, and there's a lot more organic material included in that superficial ochre, as we're calling it, or that paleosol, relative to in the cave, where basically all that organic material was originally there is decayed. So we're dealing with a much higher purity. It also has, as Brandi mentioned, higher amounts of arsenic, which again we're finding very curious, but we still don't really quite know the end use. But there's some very good reasons why they were actually extracting the ochre from the cave systems. So the ochre in the cave is possibly washing in from the surface through cracks and also through some of the cenotes, or these openings into the cave systems. And it's also, in particular in the Sagittaria, we think it's also related to, it's geologically old ochre. So this is a picture from Bermuda that I borrowed from another publication. It's just a very nice example. And this is basically a soil pipe of this red ochre that's sandwiched in between limestones from this. This is an example from Bermuda. And here's sort of a diagram that kind of explains the sort of process that we think would expose the ochre on the bottom of the cave. So this is the limestone, this is the soil pipe, or the ochre within the limestone. And then I've got the cave formation and cave passage formation, which is then basically cut through that transition and has left some of that original ochre in the bottom. With Sagittaria, we're finding it, as Jim was kind of showing, these broken up cave bottom and the flow stone. Some of this is getting transported and getting sandwiched in between cave formations. So they were actively breaking that floor up to actually extract the ochre, which would require an awful lot of effort, time and effort, to be able to get at the ochre. The other kind of interesting site that we found subsequently is this one that's from Camilla, which is further to the south, so it's 50 to 60 kilometers away. So, suggesting that we're dealing with a regional sort of extraction of ochre. That brings up some kind of important ideas in terms of prospecting for, new sites, which I'll kind of talk about it in a minute. But what's very interesting about Camillo is that this was ochre that wasn't sort of really readily exposed on the bottom of the cave, or it doesn't appear to be from what we're sort of seeing. And it was in the limestone, and they had to break up, you know, the bottom, and it's very thin layers of this ochre, and they were basically mining it out, but they were using basic geological principles of kind of correlation and stratigraphy, which we're kind of seeing in terms of, you know, the pits and where they're placed. And this kind of illustrates, you know, that they'd probably mine out the sort of little bed of ochre, and then when it kind of petered out, they would go, oh, I'm just going to move over here, and I'm going to start a hole, and then I'm going to go to the same depth. So they seemed to be going to the same depth. So they understood this kind of concept. I don't need to go any deeper to find that ochre deposit. So it's these sites are really a wonderful window into that process, into this industry that we haven't had before. I mean, you know, it's this flooding of the cave systems and cutting the cave systems off have produced this impeccable preservation. It's like all the mining tools are there, and they're just, you know, it's flooded, and then just everything stopped. You know, they just left everything. Sam likes to use, turned the lights off and went home, and nobody came back. So really wonderful window into this time that is, you know, really, you know, there aren't many examples or any examples of this that we currently have. The other kind of interesting idea is, like, you know, we're sort of seeing the extraction sites, and we have a very good example with Mina. And you know, there's important ideas here in terms of, okay, well, once that deposit basically is exhausted, I mean, well, we got to go find another one. I mean, how did they know how to do that? You know, we're seemingly able to find other sites now relatively easily. And it looks like we're dealing with a very widespread sort of process. So how did they do that? You know, maybe we'll be able to, with more sites, be able to actually understand that and get, again, this unique window into that time. And that's all I have. And this is just a quick video showing me sampling one of the ochre pits in Mina, and you can see the kind of red kind of sediment kind of coming up as I'm sampling the wall. What's nice about this shot right here is that you can see the original fill line of the ochre in the cave bottom. So you can literally calculate the volume of material that they removed, and then the spoil all around. You know, when I saw this site for the first time, when Fred, one of the other team members, kind of showed me, and talking to Sam about it, and also Chris, I mean, very, very exciting find, very, very exciting site, and really, really excited about continuing with this work.
All right, thank you so much. That gives us a really great overview of the work that's being done. We have one more speaker, and then we're going to open it up for questions and answers and a short 15-minute film. And I'm especially pleased to introduce our next speaker, Explorers Club fellow Sam Meacham, who I've known for over 25 years now. Sam is the director for Quintana Roo's Aquifer Research Center in Mexico. Sam is a prolific exploration cave diver who's dedicated his life to understanding the dynamics of the Yucatan's karst aquifer and those affected by it. Sam will share a vision of the work of exploration and discovery, as well as the interpretive outreach efforts and science achieved through mapping, 360 video, and photogrammetry. And again, following his presentation, we'll have some questions from people as far away as Malaysia and the Arctic Circle, and then we'll follow that with a 15-minute film. So Sam, it's all yours. Oh, you'll have to unmute, Sam.
Thanks, Jill. And thanks to all of you for joining us here tonight. It's what sitting here and watching everybody speak about what they do, for me, kind of hits home with just how incredibly wonderful the work I get to do is, and we get to work with experts in all of their fields. And I think 2 years ago, Brandi probably didn't know that cave divers exist. I certainly didn't know that ocher experts existed. And what we do in our work is really try to facilitate the research around not only the cultural heritage, but also the natural heritage of the incredible resource of the cenotes and underground rivers. So I'm gonna share my screen. Thank you all of you for being here tonight. And I also want to also thank all of our patrons that support our valuable work. Without them, none of this would most likely happen at all. So we're very, very grateful for that support. As Jill mentioned, I represent SINDAC. It's a nonprofit I helped to start here 20 years ago, and together with my colleagues and friends, Fred DeVos, Chris Lamayo, Daniel Ponce, and Julien Fontaine, we are committed to, again, helping to facilitate research. And on this project, and in many of the projects that we're involved in, we wear many different hats. As the original exploration that we conducted in the mine portion of this cave, and then as the arms and the eyes and the hands of the scientists that can't visit these sites. It's just a real pleasure to be able to provide that link from the scientific community to our expertise and knowledge. You can learn a lot more about our work. I have a limited amount of time, but our website is here, sindac.org, and I think Kevin's also putting that up on the chat. But you can learn a lot more about what we do and what we stand for on our website. In fact, there's a specific site set up for the mine there. So I briefly want to talk to you about the documentation of what we did in Sagittario using both photogrammetry and 360 video. You're going to be able to see on our website examples of the photogrammetry. On our YouTube channel, you'll be able to see the 360 video. If you have augmented reality VR goggles like the Oculus Go, you can stream the 360 video and actually literally come on a dive with my friend Fred DeVos and myself as we dive through the mine. So it's incredible leaps in technology. I've never been more excited about what we do because of the technology we have in our hands that allows us to take you with us into these places that otherwise you would not be able to visit. Technology is really driving a lot of the work that we do here. And the genesis of everything that we're doing, and it's been mentioned several times here, is the Hoyo Negro project and kind of the marriage of engineering and archaeology, and in this case, underwater archaeology, underwater cave archaeology, which is an emerging discipline. And it's through the work in Hoyo Negro and my friends Beto Nava, Alex Alvarez, and Roberto Chavez, and the incredible work they've done there to create a three-dimensional model of just an unimaginably enormous space. And Dominique's laboratory at UCSD, that it may be hard for many of you to understand this, but the easy part is capturing the photographs. The hard part is in the processing of these enormous computer models that are in the billions of point clouds. So everything that we're doing in the mine comes as a result of the incredible Hoyo Negro project. So the value of photogrammetry, and Dominique touched on a lot of this, is it allows us to do site documentation and spend our time looking at it. Both the cave divers, as Dominique mentioned, we see things that we don't see when we're down there ourselves. We're pretty task loaded with what we're doing at that time. It's unbelievable to see someone like Jim pour over one of these models and pick out teeny little bones among the rocks and identify exactly what they are. The value of it, of just allowing people to spend the time to go into these sites, is incredible through photogrammetry. It aids us in our dive planning. We can be very precise in terms of how we're going to execute a dive based on reviewing one of these models and going along and seeing exactly where we're going to be and where it's going to take us and what it is we might need to recover. It does allow us to help recover things. Jim has, I've got a 3D skull of Naya here. We can make tangible replicas of whatever it is found in the cave. And of course, all of this is also an incredible educational tool. Again, virtual reality 360 videos is an emerging entertainment, really, that we think finally is helping us cave divers overcome the obstacle of taking people into a place that rightfully so they're not going to go to. So photogrammetry has many different values, and in the case of the mine, what we needed to represent was the humans having been there, the actual interaction of humans with this, with the cave itself. There are no remains there. There's no skeletons or anything. It's just as if the Tasmanian devil had gone through here and completely torn the place apart. So we picked a representative area of the cave and set about documenting it. And all of the photogrammetry that I had witnessed in Ojo Negro, I've never actually done it myself, but we purchased a Sony camera. Sony cameras are very good in low light situations. We use a 16-35mm lens, an Autocam housing, and video lights. And nobody wants to be my dive partner. Basically, when I go in to do photogrammetry, I'm worse than any kind of underwater photographer. I took 18,000 photographs to create the model that Dominique showed you. Again, that model you can see on our website as well, and fly through the cave. But yes, you have to, it's a very painstaking, tedious task of literally mowing the lawn in obviously an overhead environment where it's easy to become disoriented. So my poor dive buddy just has to sit there while I go back and forth and all around taking endless pictures, which we then put into Agisoft software to create the models that we have. And we have limited computing power here in Mexico. And again, it's thanks to the incredible resources at UCSD that all of these models then can merge together. And this is a screenshot. We actually have an example of this. We have some smaller representations of models on our website. One of the is this one here. And really, this is when Fred DeVos and I did the initial dive into this area. This is when we saw this particular site right here, it was what made us scratch our heads. And we've been seeing stuff like this throughout the years, but we could never really explain it. A rock out of place or a broken floor, and it just didn't make sense. But when we saw it in the magnitude that we saw it in the mine, we knew we were onto something. And you can see, and Jim pointed this out, just the incredible broken edge, and then the spoils piled up behind here. And so that's when we immediately, we got out of the water that day from that dive, and we could not stop talking about what this might represent. And what ensued is 3 years of study and a publication, and we're very proud to have been part of it. Finally, we just had really this fall out of the sky for us, but in May of 2009, Foxfish Research and Russell Hughes, who represents Foxfish, came here with one of their high resolution 360 cameras. And it wasn't a hard decision for us to put it in the mine. As we joke, it takes a lot of light to make it look dark. And you can see Fred here in the upper picture with his insane lightsaber-like lighting conglomeration here. Again, on our YouTube channel, there's about an 8-minute video, and it's all around. You can see the ceiling, the floor, all around us, and Fred and myself as we're diving through. It's very nerve-wracking to fly a 360 camera through such a delicate space because it sees everything. So fortunately, we got it all in one take without running into anything and embarrassing ourselves. But really, this is what we're aiming at here. And again, 99.9% of the human population will never physically go to any of these places. And that's good because they're delicate and important sites that need to be protected. But this is what we can do. And one of our main goals at Syntac also is educational outreach. And so one of our greatest obstacles has always been to get people to understand this environment that we go into. And it really is just the most surreal and beautiful place that I can imagine. But obviously not everybody shares that opinion. And so what VR does and what these models do is go beyond even traditional photography and video and allow us to take you, the general public, with us. And I'm very happy to announce that we're working with our local planetarium here to create an exhibit with all the content that we have created. And it's not hard to imagine that that same content could be used in any museum around the world for any of the different sites that we've documented. So in closing, I've never been more excited about what I do. I think what gets us out of bed every morning is not the fact that we found something like this, it's what we haven't found yet. And there's so many more things in terms of exploration here on the Yucatan Peninsula. It's still just wide open, and it's just an exciting place to be and to explore. So thank you all again for joining us tonight, and thank you, Jill, again for putting this together. The film that you'll see following questions and answers, if you stay around, you can talk more about our discovery and some interviews with Fred and Brandi and Ed as well. So thank you.
All right. Thank you, Sam. And thanks for your tireless efforts. I mean, not only do you become the hands and the eyes of scientists, but all of your work and the technology enables people all over the globe to go with you to places that people have never seen before. And that's extraordinary. So we have a lot of questions from our viewers around the world, and I'll just try and hit on as many as I can before we switch to the little film feature. But there's one question that's been repeated many times, and maybe I'll ask Sam this one is, how far in did these miners go from an entrance to the mining sites that you found?
Yeah, so there are three principal entrances to this cave system that we know of. There potentially could be more, we just haven't found them yet. But out of two of the entrance, almost immediately there's manning activity. And from one of them, there was not so much. And if you stick around to see the video, you'll see kind of the progression of our exploration. Took us up over an air dome, and then through the other side of that air dome, there's what we call a restriction. And it's about, my mother, I think, is watching. She might want to turn this off, but it's not very wide, and we had to squeeze through this restriction. And on the other side of that is where the real mining activity that we first began to see was taking place. So it seems like they might have been physically constrained in some portions. For us to get back from the easiest entrance we have to get into, we have to travel about, I think it's about 750 meters to get back there. The whole cave system's about 12,000 meters, if I'm not mistaken, of surveyed and mapped passageway. And it's important to state also that mapping and cartography, and I'm saying this for my friend Peter Sprouse, is extremely important. It is the foundation of everything that we do, and it fixes everything into real space. All the sampling that's done, all the documentation that's done, fixes itself on the physical map of the cave system. Cartography is still extremely important in what we do.
Indeed. Thank you. Brandi, we have a question for you. There are a lot of our viewers that are really worried about the miners and their contact with this ochre material that has high arsenic levels. Was this detrimental to their health, do you think? And do you find it in any of the bony remains that have been discovered in the Yucatan?
That's a great question. I couldn't tell you if it's been found associated with bony remains, but what I could say is that certainly long-term exposure to ochre that has very high trace concentrations of arsenic could have caused some chronic issues related to some chronic toxicity, I would assume. If they were constantly covering their bodies in it, that does absorb through the skin to a certain level. So it could have happened if that's what they were using it for.
Okay, thank you.
Maybe I can add in there about the human side of it, the impact on the skeletons that have been found. Skeletons are often found, Paleo-Indian skeletons in particular, coated with red ochre. And many of our early Homo sapiens ancestors, as they spread across the globe into Australia, across Siberia and into the Americas, were buried in large quantities of red ochre. We haven't yet looked, though, to find out whether, one of the thoughts we've had is that arsenic may have been one of the reasons people were using the red ochre, is because it would be a good insecticide, or at least something to at least keep the lice out of your hair. And I'm interested in looking to see if we can detect that arsenic in the human tissues of the skeletons that we find. That's a piece for future research.
Great, thank you. Dominic, we have a question for you from one of our viewers. What is the most surprising find that you've been working on?
For us, wow, my goodness. I guess it depends on the project. And you know, I guess it's important to note that, you know, many of us topside who are working with these data, you know, we're not the discoverers, but occasionally there are things that are discovered in these images, in the data, and you know, Jim could attest to that as well. You know, when we take these virtual dives, very often with you know, with our colleagues, with the dive team, you know, things start to emerge. And so I think what really I think is most exciting for me for many of these caves, since as a cave archaeologist interested in site formation, is our ability to reconstruct the site formation and transformation processes using these digital twins. And so there are a number of different kinds of interlocking discoveries that have to do with the story of how these sites formed as sites, where these animals came from, you know, how they fell in. Did they fall into a flooded cave? You know, were they negatively buoyant when then they became positively buoyant? They start moving around and their carcasses come apart. And there's a whole story about why we find the bones where we find them, that we can look at the articulation and disarticulation of bones by using these digital twins to start piecing together the site formation story. So along the way, there are dozens and dozens of little discoveries that are part of really being able to an exciting kind of archaeology. Even if we'd rather be diving, we still can learn so much about the site using these tools and techniques.
Great, thank you so much. We have another question from Llewellyn online, asking whether there is a chance for using crowd-based experts or public viewing to try and spot items that you guys might have missed. Maybe Sam should answer that one.
No, Dominique.
Or Dominic, yeah.
No,
Dominique.
well, you know,
Okay.
This is certainly being done worldwide on a number of different projects. So if we are able to make versions of these digital twins available online, you know, through the commodity internet, and give people access to those data, then, you know, whether or not it's, you know, more peer-to-peer, or whether or not you want to put these kind of data out there for people to explore, it's going to result in additional observations and discoveries that, you know, may have eluded the experts. And so this is something we've explored a little bit. You know, we're working also with the gamification of sites, say like Hoyo Negro or like La Mina, where people can interact in a slightly different sort of way with these data on this sort of virtual exploration. You know, and in my process of doing that with a group of students here over the summer who are a neurodiverse group of students with autism spectrum disorder, they've, you know, see things that I could have never seen in these sites, because they're applying different intellectual skills and different perspectives. And so, you know, it would be really interesting to start opening, you know, corners of our research up to put different eyes and minds, you know, on this type of work.
Thank you. This next one is probably for Sam. I mean, you've worked, you know, a lifetime exploring and discovering, you know, remarkable things in these underwater caves. And I guess what I'd ask for you is maybe a comment to the cave divers that are listening tonight, as they find things that they wonder about or may have questions about. How can they work with you or with Ina to participate and offer things that they've found in underwater caves for, you know, in the interest of protection and also outreach and education?
Well, I think Roberto also is very qualified to answer this, more so than I am. But we work with the Subterranean de Arqueología Subacuática, and whenever we find something, we're very careful never to disturb or touch anything. You have to realize that archaeology is very much a forensic science, and it's like a crime scene. So the moment you move or disturb anything, you've basically contaminated that site. So we're very, very careful, and I think anybody that comes across anything needs to be very aware of that. Roberto mentioned the UNESCO Convention on the Protection of Underwater Cultural Heritage. Actually, SINDAC is right now in the process of applying to be an accredited NGO recognized by UNESCO and one that respects the convention. And I think it's worth everybody reads the convention to understand how important it is, because we only get one chance with all of this stuff. And it's so absolutely important to study these sites correctly. So I would just, report the sites. There's, you can do it anonymously if you feel like you have to. But working with Roberto, and I have to say that our thanks go out to Pilar Luna in particular, and Roberto and the whole team at INA that really just put an incredible amount of faith in our abilities and our skills to go out and do this work. And so the other thing is just to be respectful. And some of the Maya sites we have here, they're burial sites, and we have to be very, very respectful. Those people were put there in that place for a very particular reason. Roberto, I don't know whether you have.
Well, I don't know. For us, it's such a pleasure to work with scientists, explorers like you guys. I mean, I think we make a good partnership as stewards of underwater cultural heritage, and we're taking it to the next level. And for us, it's such a privilege to be able to work with you, and we're very thankful. And I think that together we're moving things forward in the knowledge of the past, in terms of the heritage of our country and of humanity, and so we are very thankful, really. Thank you.
Thank you. I'm going to have one more question before we move on to our film feature. And this is an interesting one for Brandi again. Are there any clear connections between the old world use of ochre and the new world use that might indicate some sort of cultural continuity? And Brandi, you'll have to unmute. Yeah.
Yeah. I'm thinking actually of how to answer that question. That's a good question. It's very broad. It would be a very broad generalization to make any direct comparisons. We can say that there's a lot of commonalities in terms of how ochre has been used for tens of thousands of years, if not longer. The one that comes to mind particularly is rock art, because we find rock art on almost every continent of Earth and throughout almost all of human history. And so I think early on, engaging with the mineral and understanding its properties was something that we understood as a species how to do very quickly. And so that was spread around the world along with all other types of technologies, stone tool technologies, hunting technologies, seafaring technologies. And so I think it's sort of part of material culture and human behavior that started very early. So.
Okay, thank you. Well, I think at this point we will go ahead and run the 15-minute film presentation, but please stay with us for some important thanks and closing comments afterwards, as well as some announcements about some exciting new club lectures that are coming up very soon. So Kevin, if you could roll our film for us, I'd appreciate that.
Here was very clear evidence of what people were doing, many, many thousands of years ago, some of the first peoples to inhabit the Americas. And we're seeing sort of a time capsule of their life then.
It's really hard for me to think that 2 years ago we would discover something like this, and much less I'd be sitting here telling anyone that we'd found a flooded prehistoric mine, but there it is.
My name is Fred DeVos. I'm originally from Canada. I've been living here in Mexico for more than 23 years and have dedicated most of that time to the exploration and documentation of the area's underwater caves.
My name is Sam Meacham. I'm originally from the United States, and I've lived in this area since 1994, and for the majority of that time, I've been involved in the exploration and mapping and more importantly, education about the aquifer for this area.
The formations that we see from the ceiling, on the floor, in the form of stalactites, stalagmites, proves that these caves were once dry.
There's probably at least 10, if not more, human skeletons that have been found within the caves, not to mention elephants, giant ground sloths, saber-toothed cats, a kind of a zoological collection of Pleistocene fauna and megafauna. So we knew people had been going into these caves, but we'd never really seen direct evidence of them being there other than their remains.
So we were approached in early 2017 by the original explorers of this cave to help them with mapping and documentation of what they had found. And from there went on to explore almost 6 kilometers more.
Pretty much like I'd say any dive that we do, we're always just going out to further the knowledge base of the extent of these cave systems, never really with the expectation. I mean, we always have the hope that we're going to find something, but we never know what we're going to find.
So during the exploration of new passages in Sagittario, Sam and myself began to see damages to the cave. And what I mean here is broken speleothems, misplaced rocks, things that didn't seem natural to us. Because it was original exploration and no divers had been in this passage before, we were convinced that we were onto something very unique.
So as we're exploring, we're going through a fairly large passageway that ended in an air dome, and we came up into the air dome, very beautifully decorated, lots of pretty speleothems, and we went across the air dome and down the other side, and there was a fairly major restriction on the other side.
But through the restriction, we felt that the flow of water was continuing. This is usually a very good sign to explorers, meaning that there must be cave beyond the restriction.
Fred told me to hold, and then he went down feet first through the restriction. He indicated to me that it was okay to pass, and so I went through, and that's really when we first saw the overwhelming evidence, irrefutable evidence of human manipulation of this cave.
What we found on the other side was absolutely incredible. Rocks being smashed.
An abundance of charcoal, which could have been naturally washed in, but in the quantity that we're seeing it, in the places that we're seeing it, we're thinking this is probably evidence of fires.
Boulders too large for one person to carry, piled up on top of each other.
Rock cairns marking the center of the passageway in a lot of these areas that we're diving through.
It was very clear after spending time in what we named the mine, or La Mina, that what these early visitors to the cave were after was the sediment.
People are literally breaking the floor, piling rocks up to get at the sediment from down below.
And not a little bit of it. Tons, literally tons of sediment had been removed from this cave. We are not archaeologists, but immediately we realized the importance of La Mina in terms of archaeology. And we really hope that everything we do can help archaeologists to answer important questions about the first inhabitants of the Americas.
Any scientific study these days is multidisciplinary. It requires a great deal of collaboration between ourselves, the divers that can go into this environment, and the non-diving scientists that we work with. And so one of the greatest obstacles is just that, is that the majority of scientists that we work with will never be able to go into this environment. So what can we do? What technology can we employ that best enables us to take non-diving scientists into this world? Underwater cave archaeology is very different than archaeology of a shipwreck, let's say, in that a shipwreck falls arbitrarily on the bottom of the ocean floor, whereas in the case of underwater caves, the cave itself is very much a part of the story of how people traveled through this. So we really have to map the whole thing to tell the entire story. So the map is really the critical first step that we do to bring scientists into this world. Another technique that we've employed in Sagittario is that of photogrammetry. And photogrammetry is something that's existed for a number of years, but with digital cameras now and with better computing power, what we can actually do is create three-dimensional models from photographs. This is really an incredible opportunity to allow non-diving scientists to explore and observe within the cave and then get back to us with potentially specific tasks or areas they'd like us to revisit to collect a sample or take more higher resolution photographs to document that site. Maps are wonderful. The 3D models that we can create are incredible. But what really just literally fell into our laps in May of 2019 was the opportunity to try out a 360 underwater camera. Thanks to Boxfish Research, who produces this camera, they pretty much let us have it for 2 straight weeks. And it wasn't a difficult decision to take it through the mine. And so, again, one of the greatest obstacles we have in educating people about this beautiful place that we have the privilege to go into is getting them beyond their preconceived ideas that we're a bunch of daredevils, and in fact show them just how beautiful the underwater caves of this area are. And never had we experienced anything like this until we got to try out the 360 camera. In a work like this, collaboration is absolutely critical. We're very grateful to the involvement of INA, the National Institute of Anthropology and History, and their Underwater Archaeology Division. Pilar Luna and Roberto Junco really are the ones that allow us to be able to do this work and bring our expertise to bear with the rest of the scientific community. Ed Reinhardt from McMaster University and his team are really doing a great job in helping us determine sites that might need to be sampled. Brandi MacDonald from the University of Missouri and her analysis of the sediment is giving credence to the fact that yes, indeed, that was what they were after. Dr. Barry Rock at the University of New Hampshire is actually taking the charcoal samples that have been found in the cave and looking at them under a scanning electron microscope and can tell us exactly what species of wood this was that was being burned in there. But we can also, from those same pieces of charcoal, get carbon dates as well from Jim Chatters of Paleoscience. And finally, the University of California, San Diego and the Cultural Heritage Engineering Initiative is really the driving force behind all of our photogrammetry in this area. And it takes a ton of computing power to put these models together. The work that they're doing out there, the truly pioneering work, bringing engineers together with artists, architects, and archaeologists is absolutely mind-blowing. So I think it's really hard for a lot of people to grasp why anybody in their right mind would do what we do. And my true hope is that in seeing the mine, from our own perspective, to connect in such a dramatic way with the first inhabitants of the Americas really is just such an overwhelmingly humbling thing to experience. And to know that those people were coming in here and working at the scale that they did to excavate this mine and bring material in so they could build fires and then break the rock and then excavate and take things out, it's absolutely beyond my comprehension. The amount of energy and time that would have taken. These people couldn't just go to the convenience store and get a nice ice cold drink at the end of the day. They had to worry about short-faced bears and saber-toothed cats and any number of other things, including just a minor scratch that could have proven to be fatal. So these people, they're living on the same planet, but in a completely different world than we are. And I have nothing but respect for what they were able to do.
Over the number of years diving caves in this area, we have seen evidence that led us to believe that humans had been in this cave before us. But we never really could prove the manipulation of caves by humans until we found the Mina.
One of the main motivations we all have is, what are we going to be telling you a year from now that we've discovered in one of these caves? The possibilities are limitless. And for me, that is absolutely one of the motivations. It's what we haven't found yet. And I'm quite sure there's even more spectacular things than what we're showing you in the mine right now.
Wow, thank you so much for that incredible imagery that is such a great summary of our evening tonight. I want to thank our speakers once more for their excellent presentations and their ongoing important work safeguarding and interpreting the cultural objects and stories of Mexico's past. Their efforts give us a glimpse of the earliest inhabitants of North America, as well as the future of scientific, artistic, and engineering collaborations that help describe our world. Thanks also to the Explorers Club for offering this incredible educational opportunity The efforts of the club and people like Ann Passer, Deanna Weibel, and Kevin Murphy give us all a chance to engage in exploration and access the remarkable stories from explorers you met tonight. Please continue to support the club and their outreach initiatives by visiting explorers.org and the associated channels on YouTube and Facebook. Also, remember to visit Sam's site at syndac.org for some of the further experiences that you've heard about tonight, like watching the 360 video or using your Oculus headset to explore further in La Mina. I want to also bring your attention to the next club lectures that are coming up. This Thursday on Chapter Connect, we visit with the Southwest Chapter Chair, Robert DeMeo, and one of the presenters will be George Venny, the president of the International Union of Speleology, and he'll share with us about the International Year of Caves and Karst. On January 25th, you can join us for a talk about plate tectonics and great earthquakes hosted by Lynn Sykes. And then the next night, a follow-up on January 26th, when disaster strikes, readiness in the field and at home, with disaster busters, George Coronis and Jason Harper. So again, thank you to our extended audience and our speakers tonight, and please join us again on the Explorers Club series. Good night.